Alright. Questions on 10.1 first. We have to do the finish that. 10.1. Do we have any questions? No questions on 10.1. Alright, 10.2. 10.2. What now?
She's trying to find. I had. Yeah, 21.
Number 21? Okay, so let me just draw the circle first. Okay, they tell us that AD and CG are diameters. So AD is a diameter and CG is a diameter. Without even looking to see what I'm finding, if AD is a diameter, that means that it's going through the center of the circle and it cuts the circle how? In half. So I can easily find the angle that's missing, which was ABC, by saying 180 minus what?
55.
And what would that be?
125.
Okay, then if I'm looking here, I have another diameter. So that means that from C all the way around to G has a sum of what?
180.
180. So to find this angle that's missing, I would say 180 minus 55 minus 35, and what is that?
90.
Okay, so on number 23, was that it? Is that what you told me?
No, I was asking if 21 was a semicircle.
Oh, yes. 21 is a semicircle. A, C, D. Yep. So nobody has a question on any of those? Well, let's just work 23 for fun. The measure of ACF. So we start at A, we find C, we wouldn't go this way because F is before that. We have to go to the left rotation. So A all the way to C, and then all the way back to F. So how could we find the sum of the arc measure by doing that?
360. That's all.
Well,
Find
from,
out the missing measurement.
would we have to know that missing measurement?
No, you could just add them all.
We could just add from A all the way to F. This would be 125, arc 125, AC is 125. CD would be what? 55, and DF would be 90. So we literally just go and add 125 plus 55 plus 90, and that answer is 270. Now, if we knew this value right here, we could just subtract, couldn't we? 360 minus 35 minus this, but we don't know it. We could easily find it. It's what? 55? And then we could subtract 360 minus 55 minus 35. Either way is fine. Okay, so let's keep on with our notes. We have a little bit to finish. Okay, so here we're looking at female participation in sports. And this is basketball, track, volleyball, softball, soccer, and then other. So we're looking at female participation in sports. We're given a circle with percentages on that circle telling us how many percent of the girls participating in female sports actually participate in basketball, or what is the percent of girls that actually participate in soccer. Okay, that's what that percent is representing. And then we have the arcs, or the endpoints, all the way around the circle labeled. That's A at the top. Okay, it says refer to the circle graph, and we want to find the measure of arc CD. Find the measure of arc CD. Well, the problem is I don't have any angles. I just have percentages of the circle. So if CD, what does CD represent? What sport? Volleyball. So CD, the arc CD, has a value of 18% of that circle. But what is the whole circle? 360. So it's not saying 18 degrees out of 360. It's saying 18 what? Percent. So what is 18% in decimal form? 0.18. So I could take 0.18 and multiply that by the entire circle to find the degree of that arc. So 18% times what? 360 is going to give me the measure of arc CD. So what would that be?
65.
Let's round it to the nearest 10. So arc CD is 64.8 degrees. Okay, what about the arc BC? The measure of arc BC. What is the percent of kids or girls that are involved in track and field? 18. So do we have to even rework that? No, we've already found one arc that had 18 degrees of the whole circle, so we just know that arc BC is going to be
64.8.
64.8. So we're referring to arc BC when we're looking at this. So B to C has 64.8 degrees. So 64.8 degrees represents how much of that circle is engaged in track and field, or volleyball, whichever one you want.
26. Or 30.
Alright, what about EF? Y'all do EF, the measure of arc EF. What was the percentage? 14%, right? So 0.14. If you move that to put it in decimal form, times how much? 360. Maddie, why are you telling me 360?
That's the whole circle.
It's the whole circle. It's 14% of the entire degree measure of the circle, which is 360. So what was that answer?
50.4.
50.4. That makes sense. Everybody good with that? Why do we have to multiply it by 360? Because it's the whole circle, and we're only given percent. So we're looking for how much is that percent really representing. Alright, what does adjacent mean? Beside it, right? So if I have two arcs that are adjacent, that means that those arcs are going to be right beside one another, correct? So I'm going to draw a circle, and I'm going to show that I have a radius of MH, a radius of MJ, and a radius of MK. So MH, MJ, and MK. Those two arcs are adjacent, aren't they? I would have arc HJ would be adjacent to arc JK. So arc HJ is adjacent to arc JK. So, because I have that, if I know the value of HJ, and I know the entire value of HK, I can use something called arc addition postulate. Don't we already know segment addition? Don't we already know angle addition? So now I have something called the arc addition postulate. And all that says is that you can add the two smaller arcs and set them equal to the large arc. So the measure of HJ plus the measure of what?
JK.
JK is equal to the measure of the large arc, which would be HK. So just real quick, like if I tell us that HJ is 25 degrees and the entire arc is 105 degrees, not drawn to scale, could I find the measure of arc JK?
It'll be 80.
Because you said 105 minus what?
25.
25. And then this would be 80, just by using arc addition postulate. So it's the same concept we've been doing since the beginning of school, but now it's in an arc or on a circle versus a segment or an angle. Okay? Alright, so you look on page 710, and let's look at 7, 8, and 9. Two 10, 7, 8, and 9, yes. I'm going to draw it first. So I have circle V. And then the endpoints on the circle, QP, Q and P and R and S and T. It says that QS is the diameter of the circle V. Why would it tell us that QS is the diameter? What does that tell us? It's making the 180 degree for the semicircle, right? So if QS is a diameter from Q all the way to S measures what?
180.
180 degrees. So in the very first problem, it says to find the measure of arc STP. So how can I do that? To find STP, I know that ST is 75 degrees. I know that PT is 72 degrees. So how do I find just STP?
75 plus 72.
So Maddie said 75 plus 72. Is she right? Are they adjacent? Yes. So what's 75 plus 72?
147.
So therefore, the measure of arc STP is 147. Okay, number 8. I'll let you do that one, and then we'll go over it together. The measure of QRT. So how would I find the measure of QRT? What? Q, R, and then we stop at what? T. So how do I find that? What do I know about QS? What does it measure?
180.
It measures 180. So all the way around measures 180 degrees.
And then add 75.
Okay, so Wyatt said we take 180 and add 75. Wyatt's correct. So 180 plus 75 is 255. Okay, last one on that page for this example would be the measure of PQR. So we're starting at P, going to Q, and then going to R. So we already found, or we already know that QR is going to be 90, right? So that's 90. All I have to find is QP. How could I find QP?
Take 180 minus 75 minus 90.
Very good. And what would that be?
53.
And that means that QP is also 53. And now I can just take 90 plus 53.
143.
Are y'all sure that's 53?
No, that's
72?
33.
Okay. Thanks. So then it's 123.
23.
Good job. Okay, so let's keep going. Let's look at the last example. What we've been finding is the degree of the arc, the measurement of the arc in degrees, not in length. Okay, length, arc length, the definition of arc length is the distance between the endpoints along an arc measured in linear units. So what's the difference between arc length and arc measurement? What's arc measurement given to you in? When we're just finding, yes, degrees, that's correct. Now we're looking for it in linear units. So arc measure is in degrees. If we're looking for the length of the arc, we're looking at a linear unit. Okay? So to find how to find the arc length, if I tell you that L is the length of the arc, and if we're talking about the distance between the endpoints, what else contains distance out of our formulas that we know? The distance around a circle, what is that? The circumference. So we obviously have to use the circumference formula here in order to find the arc length. So in our book it tells us that if you know the length of the arc over 2 pi r, now what does 2 pi r represent? The circumference is equal to x meaning the measure of that arc that you're actually looking at. So this is the measure of the arc, and that would be in degrees, over how much of the entire circle do we know? What is the circle?
360.
360. So it's really an easy formula if you think about it. You're just taking x over 360, you're finding what percent of the circle has been used, and then multiplying it by, setting it equal to L over 2 pi r, which you would end up cross multiplying.
So x is going to be in degree?
Yes, because it's over 360. If you think about what that means, you're saying this much of the circle is being used. Okay? Alright, so let's work an example. And the only reason this gets a little confusing is because we don't learn the difference between arc measure and arc length. Measure is in what? Degrees. Length is in linear units. Okay, so the directions here say find the length of zy. So we're looking for the length of zy. The difference between this example and the ones that we've already done, they weren't saying find the length of zy, they were asking us to find what?
The measure.
The measure of zy. Measure is in degrees, length is in linear units. You see that unit over there? What's the unit?
4 inches.
Inches, right? So that's letting us know that I have a unit, and I'm going to apply that unit in my answer. Okay, so the length of ZY, we learned that it is L over what?
2 pi.
What y'all answer? 2 pi R is equal to X over 360. So what is the degree of the arc?
75.
75. This is 75 degrees. So I would say 75 over 360 is equal to
4 over, would it be, did you put that 4?
So do I know L yet?
No, because
No.
you're looking for the whole length.
Right, I'm looking for the length of the arc. I'm looking for ZY, the length of ZY. But I do know the radius. What's the radius? 4. So 2 pi times 4. So I'm just going to cross multiply 8 pi times what number? If I cross multiply 8 pi
75.
times
75.
75, and then I'm going to divide that by what?
360.
360. If you're kind of, what did she just do? I just didn't show the step of 360L equals 8 pi times 75. I didn't show that step because if I'm dividing by it, I'm going to remain to divide by that number. Okay, so what's 8 pi times 75?
1,884.9555.
Okay, give it to me in terms of pi. Just really, we're looking for 8 times 75. And what is that?
600.
So 600 pi over 360. If I wanted that to be an exact, that would mean you would leave pi in your answer, right? Okay, and then you would reduce 600 over 360. I'm now going to ask you to round that to the nearest hundredth. So it's going to be a decimal approximation. It's no longer exact because I have taken the decimal for pi. What is that?
Is it 5.53?
5 point,
23.
okay, does it round?
Just
No, it's
24.
What else?
It'd be 24 because of 5 rounds to 3
Okay, so 5.24, and it would be in
inches.
inches.
This is probably a really stupid question, but in 2 pi 4, did you multiply the 2 and the 4 and then just leave the pi, or?
I did.
Okay.
I always leave pi until the very end because it may not ever ask you to evaluate pi. Evaluating pi means pressing pi on your calculator. It may say put it in exact answer form. Exact means you have to have the symbol for pi in your answer. If it says round it, then you would round in the end.
So
Okay.
it's just easier to just leave it.
Yeah, just leave pi alone, let it just be pi, and then until you get to the end of the problem, and then evaluate it according to what the directions are asking for. If I am building a house, or if we're looking at something that we need it to be precise, we don't ever want to round in the beginning. We want to round in the end. Because sometimes rounding in the beginning makes your answer become skewed or be off. And we don't want that to happen. Alright, I'll do this one. So the diameter is 10. The measure of YXZ is 130. And I want you to find ZY. The length of ZY. Now we could find the measure. What's the measure of ZY?
130.
130. So I know the measure of ZY, it's 130 degrees, but that doesn't help me find the length of the arc without using the formula that we know. So you find the length of ZY. You are given the diameter. The diameter is 10. Let's leave it in exact this time.
Good question.
Okay, who would like to go to the board and show us how to do it? Thank you, Sarah Kate.
Not done.
Okay, we'll help you out.
1 second.
Alright, Sarah Kate is going to show us or help us find the length of arc ZY. So it would be L. So the portion of the circle, which would be L, over the distance of the entire circle, which is 2 times pi times what?
10.
Would it be 10? 5. Or we could have just said 10 pi, because circumference formula is pi d or 2 pi r, right? And then equals, she said 130. What does 130 represent? The measure of the arc over 360. What does 360 represent?
The whole circle.
The whole circle in degrees. So she's cross multiplying 360 times L, 10 pi times 130. And she's dividing by 360. Okay, somebody help her out. What's 10 times 130?
1,600.
1,300. 1,300. 1,300 pi over what? 360. Now, if you left your answer like that, I'd be proud that you got it that far, but it's not complete. Why is it not complete?
You have it reduced.
We have to reduce it. So we know we can reduce a 0 off the end. So just cross out one of your zeros. Right? And now I need to reduce 130 over 36. So how can we reduce that by? Well, if you reduce it by 2, you get 130 divided by 2 is 65. So 65 pi. And then, hang on. There we go. 65 pi over, what's 36 reduced by 2?
18.
We sure will. Okay, can we reduce that anymore? I don't think so. I mean, 6 and 3 and 18, 9 and 2 are not going to go into 65. So, if I asked you to leave it in exact answer form, that would be your answer, right? 65 pi over 18, and I didn't tell you the unit. I should have. It was centimeters. That's it. Now, we could take that information and find a decimal approximation if we wanted to. Let's do that too. So, find the decimal approximation. Jody, will you go to the side door right here, and there's going to be a substitute coming in? So a female substitute will go to the door.
11.3.
11 point, let's round to the nearest tenth this time.
11.3.
11.3 centimeters. So this answer is exact because we didn't round anything, did we? And then this answer is an approximation.
What if we put both on the test?
Just to be careful, like, in case you're not really sure, well, just remember, if I say exact, I'm going to want you only to give me exact. Exact is in terms of what? Pi. If it says to round, then you would obviously find what pi is. Okay? Alright, so now I would like for us to add to what we did yesterday's homework. We're going to work on page 711, 26 through 41. through 50. So 26 through 41 and 45 through 50. And then we'll go over that and move on. So 26 through 41, 45 through 50.